Right, we've been working with Tinkercad up till now, and we're going to be moving into Arduino Create almost exclusively. You should have already copied your test of distance and have tried uploading that into the Arduino Create. I've got one more little item that I'd like you to have a look at, and that is to make sure that you go through and are putting lots of comments in the work that you're doing. I'm just going to search for QPS here to find the latest version I've got here. This is a PBL course with comments. You should really be working with comments. I'm going to copy and tinker this. You could do this yourself. I've just rearranged the layout just slightly from what you've seen. Still exactly the same. We've got a servo, if you're going to be using a servo, the two motors, the switch sitting in here so that that can run the code. Now what I've done with the code is I've gone through and added in as many comments as I can, and you really should be trying to do this yourself, because as you're working over here you'll find that those comments are really useful. So adding in things like comments 10 and 4 go to the motor controller, set the PWN, and you can see that that same information is now listed over here in the comments. That's going to go into Arduino Create. Now we learned that we can click on the download code to get it down, and then we can upload it to our computer. We could also come across here, and if we select all and copy, we'll be able to paste that into a new one directly. So I'm going to go to my code online. Remember, you're going to be signing in with Google. Once you get here, if it remembers you, and you can use a username, not an email, username, otherwise use the sign in with Google. So if we come into this sign in with Google, and I'm going to, so there was the test of distance traveled sketch. It's come back with the last one we were using. I'm going to create a new sketch, and here's my new sketch. I'm just going to highlight that and delete it because we're going to paste in all of the code that we've just copied out of Tinkercad. So this is another way of getting it. So what we need to be able to do now is to be going through and modifying the code directly in this Arduino area. So we need to be reading this, and that's where the comments are really helpful. So you might like to take a copy of what I have given you in Tinkercad and bring it across in here, and then you can have a go at modifying this, or you can add comments to your own. But your task today is to become familiar with the code that you are using for your course. Now you can see here I've got digital pins 10 and 4 high. They're used to set the direction of the motors. We don't go and use much of them after that. We've got analog right, pin 11 and pin 3. Now these are the two pins that are controlling our motors, and they are setting the motors to stop. So we're starting those off as a stop. Then we're going into reading the digital pin 7. Remember, pin 7 is our input mode to detect if the switch has been pressed. So if start is high, if digital pin 10 is high, then we're going to run our actual course. We're going to begin working, and in this case we're going to be starting the first leg of moving forwards. If we've got the servo, it'll be here set at 90. That's hopefully going to keep us going straight. And pin 11 and pin 3, my two motors, I've set them at 150. You could change it to 100. You can find out what is the best speed. You may even find that you have to have one at something like 149 and one at 150 to be able to get your model traveling straight. Remember, you've got two different motors, so they may operate slightly differently. And you're going to have to determine how long you're going to travel at that speed. Now hopefully you've been able to test your models out on the 2-second time trial. So you'll be adjusting the speed here and the delay time here to work out how far you're going to travel. Now that's the first leg, which will take us to the first turn. And then before we actually turn, you might want to stop. So you could go straight into the turn, but if you're going to stop, then we're going to set pin 11 and pin 3 to 0. That stops the two motors. We might have a delay of about 500 milliseconds there, half a second, and then we can begin our first turn, which is to the left. Now, are you going to be using a servo to turn, or are you going to do a motor turn? If you're using a servo to turn, you're going to have to determine what value you're going to have in terms of the angle of the servo, and depending on which way up the servo is, it could either be above 90 or less than 90. So I've set this at 100, but you'll have to determine that depending on your particular model. And you'll also have to set a speed for the two motors. I've currently got them at 0. If you're not using a servo, of course you delete this part, and you will have one motor going at a certain speed and perhaps the other motor not going at all. And then you'll have to determine how long you will have them running. Now that's likely to be a very short period of time, because you're just really trying to rotate on the spot. So that could be in the region of 250 rather than, that's a quarter of a second rather than a whole second or something like that. Again, that'll depend on your model. And once you've made your turn, you're going to turn both motors off. You'd also reset the servo to 90 to begin the second leg if you're using a servo. And then the second leg begins. We're going straight, we're going forwards, so depending on the speed that you're going to be working with, the pin 11 and pin 3 will still be set at a particular speed, and again you'll need to determine how far that is so that you can calculate how long your motors are going to be running at that speed. So in this case I've said 4 seconds instead of the 5 seconds we had for leg 1. I think it's a shorter leg. Then we're going to turn our motors off before we go into a turn, and we're going to turn to the right. So again we're trying to calculate what degree of speed or what degree of turn we're going to need, and then we move into the third leg. The third and final leg is again a straight leg, so we have probably both motors at the same speed, and we want to then run for a certain length of time. You'll have to calculate that. Once we get there, of course, we've got to turn our motors off to stop at the finish. Then in our else statement, this is what's going to be happening while we're waiting for the button to be pressed. This is a standby, so if the switch is not yet pushed, the motors are going to be off and the servo will hopefully have turned to 90 degrees so that it is ready to start. So this is now ready to be uploaded